Hello friends, in the previous lecture we have seen the Laplace transform of standard functions and the fundamental property linearity property. Now in the lecture number 3 we will discuss about first shifting theorem, and the statement goes like this: if Laplace transform of f of t is f of s, then we have two results. The first one is Laplace transform of e raised to minus at f of t, that is equal to f of s plus a, and the second one Laplace of e raised to plus at f of t, which is equal to f of s minus e. So here we can observe one thing: the Laplace of the product of two functions, and out of these two functions one of the function is strictly exponential, whereas in the second case also it is a product of two functions, one of the function happens to be an exponential. The only difference between them is, in the first case the coefficient of t was minus a, and the second case coefficient of t is a plus a. And you can observe here, we know that L of f of t equal to f of s. When the coefficient of t is minus a in e raised to at, the result is f of s plus e. So that means the original s has to be replaced by s plus e. In the second case, e raised to at, the coefficient of t is plus a, and in f of s we are replacing s by s minus e. Okay, let's talk about the working rule to find out this particular shifting theorem. Okay, now here working rule. First point, simplify the f of t. Okay, if it is not in the simplified form, if it is not in the standardized form, then find Laplace transform of corresponding f of t. And in general, we know that Laplace transform of f of t equal to f of s. Okay, then first case, to find Laplace of e to the power of minus at f of t. Let's see how to find out this particular situation. So here, whenever we come across e raised to at into f of t, the product of two function, in the initial stage let us ignore e raised to minus at, only concentrate on f of t, find the Laplace transform of f of t. The same thing I have mentioned here. So here, Laplace transform of e raised to minus at into f of t, in the initial stage we will talk about only Laplace of f of t, that is equal to f of s, okay, as per the property. And again, look at the coefficient of t, it's minus a, so corresponding s has to be replaced by s plus e. The same thing we have mentioned here, f of s has to be replaced by s plus e, and the final result is f of s plus e. So Laplace of e raised to minus at f of t, that is equal to f of s plus e. Now let's talk about the second one, Laplace of e raised to at into f of t. As usual, first find Laplace of f of t, that is Laplace of f of t. Again, coefficient of t is plus a, s has to be replaced by s minus a, and accordingly we can rewrite as f of s to be replaced by s minus a, and it is f of s minus e. So this is what the first shifting theorem. Okay. So frequently in the problems under first shifting theorem, we may come across hyperbolic function, as we know that the hyperbolic functions are expressed as cos h of x e raised to x plus e raised to minus x divided by 2, whereas sin h of x as e raised to x minus e raised to minus x divided by 2. Now based on the first shifting property, let's talk about the problems which are based on them. So here, find the Laplace transform of following functions, and I have identified one problem, that is e to the power of minus 3t cos h of 2t. If you look at here, in the initial stage it looks like e raised to minus at into f of t. Then what is f of t? F of t is cos h of 2t. And whenever we come across an hyperbolic functions, generally we may express them in terms of exponential function. That is one possibility. If we don't want to express in terms of an exponential function, since cos h of 2t it's in the standardized form, we can directly find the Laplace transform of this particular function also. Now here, without expressing them as an exponential function, I'll take f of t as a cos h of 2t. Then since it is a standard form, So Laplace of f of t as a Laplace of cos h of 2t, and we know that what is the formula here? S divided by s square minus 2 square, which is s divided by s square minus 4. And what is Laplace of f of t? That is f of s. So we have reached up to L of f of t equal to f of s. But the final result will end up with a s minus a or s plus a. That depends on the nature of the coefficient of t. In this particular case, in e to the power of minus 3t, coefficient of t is minus 3. So by applying this property, Laplace of e to the power of minus 3t f of t is f of s, and s has to be replaced by s plus 3. Why plus 3? Because the coefficient of t was minus 3, so s has to be replaced by s plus 3. So accordingly, we may write here s divided by s square minus 4 as s changes to s plus 3. So wherever s is there, just replace it by s plus 3, which is s plus 3 divided by s plus 3 the whole square minus 4. And on simplification, this is just an algebraic simplification. S plus 3, s square plus 6s plus 9 minus 4, which gives s square plus 6s plus 5. And further it is s plus 3 divided by s plus 1 into s plus 5. This is the Laplace transformation of this given function. Now here we will roughly follow this particular algorithm, okay, just for our understanding purpose. Initially we focus on f of t. So what is f of t? If it is a real valued function which is not in the standardized form, we may reduce it to the standardized form by using suitable simplification or trigonometric formulae. Then once if it is a standardized form, we talk about the Laplace transform of f of t. And what is Laplace transform of f of t? That is f of s. So up to this there is no issue, because with the help of linearity property we can find L of f of s. Then to reach the f of s minus a or f of s plus a as the final result, we look at the coefficient of t in e raised to at. If it is plus a, f of s to be replaced by f of s minus a. If it is minus a, f of s to be expressed as f of s plus a. Okay. Next. The next problem. So here find the Laplace transform of e to the power of minus 3t cos h of 5t and sin of 4t. And in the general observation, whenever we come across hyperbolic function, okay, in this particular case cos h of 5t, whenever we come across an hyperbolic function, we try to simplify or we try to express them in terms of an exponential form. So we have cos h of 5t as e raised to 5t plus e to the power of minus 5t divided by 2. So whatever the simplified form we have expressed now, we can resubstitute here, okay. That is e to the power of minus 3t cos h of 5t sin of 4t. This is a given statement and given function. So e to the power of minus 3t we can keep as usual cos h of 5t. So this can be expressed as e raised to 5t plus e raised to minus 5t divided by 2, and this sin of 4t we can written as usual. Then so for the simplification, 1 by 2 taken outside, e raised to minus 3t, e raised to 5t, which is just e raised to 2t, e raised to minus 5t, e raised to minus 3t, that is e raised to minus 8t, and of course sin of 4t. Further, 1 by 2 has to be taken outside as usual, e raised to 2t into sin 4t, we can keep it in one bracket, plus e raised to minus 8t into sin of 4t in the other bracket. The same thing I done, okay, same thing I did here. That is, this given expression is for our understanding purpose, we may rewrite them as an f of t. So this is equivalent to 1 by 2 e raised to 2t into sin 4t in one bracket, e raised to minus 8t into sin 4t in the other one. Now if you look at the nature of the terms in this particular, okay, e raised to 2t into sin 4t, is it not in the form of e raised to at into f of t, and the second one e raised to minus at into f of t? In both the cases, f of t is sin of 4t. And initially I told you that we will first focus on f of t, find the Laplace transform, and then change accordingly s as a s minus a or s plus e. So let us talk about them in this particular way. This is just an same step, f of t 1 by 2, the same thing I have once again wrote. Now Let us introduce the Laplace transform on both this side. Okay, Laplace of f of t, which is 1 by 2 L of this first function plus this second function. Then can we apply the linearity property? Yes, because these two functions has been separated with the help of only positive sign. Linearity property is applicable over here. So further we may rewrite them as 1 by 2 L of e to the power of minus 2t sine of 4t plus L of e raised to minus 8t sine of 4t. As I told you earlier, it is each term looks like in the standardized form of FST, first shifting theorem, or the first shifting property. Then accordingly we can simplify them. What is f of t? F of t is sine of 4t, and what is the Laplace transform? 4 divided by s square plus 16, and again 4 divided by s square plus 16. In this case, s to be replaced by s minus 2 because t coefficient is plus 2, and in the second case s to be replaced by s plus 8. Okay, so here s has to be replaced by s minus 2 and s to be replaced by s plus 8. Then 1 by 2, 4 divided by s as s minus 2 whole square plus 16, and 4 divided by s becomes s plus 8 whole square plus 16, and just open the bracket, simplify them. We will come across this particular step as 4 by 2, which is 2, 1 divided by s square minus 4s plus 20 plus 1 divided by s square plus 6s plus 80. Then okay, so here Laplace of f of t, that is after 4 divided by 2, that is 2, 1 divided by s square minus 4s plus 20, and the second term is 1 divided by s square plus 16s plus 80. So rest is algebraic simplification. So we can do like this. By cross multiplication we will get this particular step, and after that on simplification we obtain 2 times 2s square plus 12s plus 100, and denominator will remain same, s square minus 4s plus 20, s square plus 16s plus 18. So in the numerator again we can take 2 as a common factor, and here we have taken 2 as a common factor, and finally we may write the result as 4 times s square plus 6s plus 50 divided by s square minus 4s plus 20, and the another factor is s square plus 16s plus 80. So this particular expression forms the Laplace transformation of the given function. So with this we can stop here only. So in the next lecture we can discuss some more problems under the first shifting theorem property. Thank you.